Chapter 23, Section 2. Basically, we're going to talk about two ideas here. One is common application of the circuits we've been talking about in your house. And we're going to talk about such things as what a short circuit is, what a fuse and a circuit breaker and a GFI do in your house. And also we're going to talk about combinations of circuits, series and parallel. First off, you've probably heard the term short circuit, but what does it really mean and how does it happen? Well, the definition is a short circuit is when you have very low resistance in the circuit. So for example, if you have really low resistance and you're connected to PG&E, you're going to get a very high current to flow. Well, high currents are dangerous, as we talked, because charge moving through wires can make the wires get hot, and if you get too large a current, your wires can get too hot and you can burn your house down. So you want to avoid short circuits. One way to avoid a short circuit is to put a fuse in. A fuse is just like a very skinny section of wire that it's so small that when the current passes through it, it gets hot quicker than the other wires in your house, and it melts and it stops the current. It creates what's called an open circuit, like a switch being open turns off the current, and then your house is safe again. By the way, think about how does short circuits occur in the first place? Usually it's when you accidentally touch a wire that should be connected to something, but you let it touch the ground. You let it touch a piece of metal. You let it short circuit, and then there's low resistance and you get the high current to flow. Now we're going to talk a minute about how your house is wired, household circuits, and I'm going to show you a picture, but first let's just read this caption here, because then we'll look at figure 11, which shows a simplified household circuit. Notice that it's a parallel circuit and it has a 15 amp fuse and it's connected in series to the 120 volt power source. That would be the equivalent of PG&E. And each resistor in the schematic you're about to see represents a light or an electrical appliance in your house. The current in each one of the branches of the circuits does not depend on the currents in the other branches. You know, your sister can be using the hairdryer and you don't care. The television is independent. This explains how you can turn on and off bathroom lights without turning on and off the television, for example. Everything turns on and off if the fuse melts, because that's safety. So look, this is how your house is actually built. We've already looked at parallel circuits. The nice thing is, in a parallel circuit, they all have the same voltage. Everything in your house is made to run on 120 volts. You can put a switch and turn on and off any one of these and not affect the other ones. Again, that's good. That's the way your house is made. And then remember, we learned that all the current that comes to these three devices, independent, different currents, all have to sum up to the total current coming out of the battery. So you put a fuse in here in series at the very beginning. That way, if you plug in things that need too much electricity or too much current, it'll melt the fuse and save your house from burning down. All right, now we've talked quite a bit now about series circuits and parallel circuits. Well, you might imagine that there's no reason why you can't combine them. And here's an example of something where we just talked. These three resistors are side by side. They're connected by wires, top and bottom, so they have the same voltage. So these resistors are in parallel. But not that resistor. That resistor, it doesn't have the same voltage as all the rest of them. In fact, it's in series with the battery, connected directly from the battery. Now, so it's a mix. We have 3 elements in parallel and 1 element in series. Sometimes people ask, they say, well, aren't these two one after the other? Aren't these in series? Well, they are one after the other, but the best definition of series is when they have the same current. And see, there's a split right there. So this resistor has more current than that resistor because the extra current went to feed these guys. So 3 resistors in parallel, 1 in series. How do you find the total resistance? This problem-solving guide is the secret. Here's a picture. They only have 2 resistors in parallel, 1 in series. And basically, you want to read these steps, and we'll practice them. But if you can find 2 resistors in parallel all by themselves, you can replace them using the formula for equivalent resistance for parallel circuits with 1 resistor. And then you draw the picture again, replacing the 2 with 1. Now you look and you say, now we have 2 resistors in series because there's no more split anymore and they do share the same current. So we can use the formula for series circuits to now find the equivalent resistance. Now we have 1 resistor that behaves the same or draws the same current from the battery as all these other resistors combined.